day possible. Desert men in for a holiday from their solitude in the sun-baked mesas. Now on whose ancestral lands bridge has been built. This is the structure they have come to honor. A spectacular steel arch towering 700 feet above the river like a gleaming cathedral in the wilderness. It's the highest and one of the longest structures of its type in the world. In its own right, the bridge is actually only one element in a greater project now in progress at Glen Canyon. Just a few hundred feet upstream from the graceful span, another structure is being erected that will be one of the engineering wonders of our modern world. It's the Glen Canyon Dam, which, on completion, will be the second highest dam in the United States, fourth largest concrete structure in the world, and one of the greatest construction projects of the 20th century. What you're about to hear is the story of this spectacular undertaking. Hello, I'm Chet Huntley. The story of winning the great American West has been essentially a story of its dams. For without water, controlled and in abundance, few of the cities, farms, industries, and recreational facilities which have made the West the El Dorado of our day would have been possible. Since the passage of the Federal Reclamation Act of 1902, the Bureau of Reclamation of the United States Department of Interior has been responsible for the erection of more than 150 dams in our western states. Some of these, like Grand Coulee, Shasta, and Hoover dams, are among the world's largest man-made structures. Our story is about the newest of these colossal river barriers located at Glen Canyon, a few miles from the once lonely and little-traveled Arizona-Utah border. The dam at Glen Canyon is the product of more than 35 years of investigation and planning by engineers of the Bureau of Reclamation. It will be the keystone of a network of dams and water storage facilities that will regulate the waters of the upper Colorado River and its tributaries to provide a dependable year-round source of usable water and hydroelectric power. As a construction project, Glen Canyon has few, if any, equals in modern times. To help appreciate the enormity of the undertaking, here is a scale model showing Glen Canyon at the time of the bridge dedication. The dam itself will be a massive structure requiring 7 years to construct and calling for over 5 million cubic yards of concrete. It will rise more than 710 feet above bedrock, measure 1,500 feet wide at the base. Its 900,000 kilowatt powerhouse will have sufficient capacity to supply the domestic needs of a city of almost 1 million people. The dam will back up the river for a distance of 186 miles to form one of the world's longest man-made lakes. It will store enough water to cover the entire state of Pennsylvania to the depth of 1 foot. The project also includes a complete new community known as Page, Arizona, with facilities to serve a population of 8,000 persons. The $108 million prime contract on this stupendous undertaking is the largest single award in the history of the Bureau of Reclamation. The successful bidder was the construction department of Merritt Chapman and Scott Corporation. The date, April 1957. What kind of a place was Glen Canyon? How conducive was it to a construction project of this magnitude? The site selected was ideal, but the remote location posed construction problems seldom encountered. Space was its principal asset. The sole inhabitants were the Navajos, scattered over thousands of square miles of desert, still eking out their livelihood in their ancestral manner. The first order of business was to open supply lines to the outside world. Miles of roads were pioneered across the desert to establish contact with the nearest railhead, 135 miles away. One of the roughest problems was transportation on the job. Glen Canyon is only 1,200 feet across, as the crow flies. For a man to cross from one side to the other, however, required a detour over some of the roughest terrain on the North American continent. One of the first construction jobs was the erection of a spectacular footbridge to permit easy passage back and forth during construction of the Steel Arch Bridge. For transporting personnel to the floor of the canyon, elevators were installed to shuttle up and down the canyon walls. Known as monkey slides, these open-air cable cars provided a sensation much like that of an amusement park parachute jump. For moving heavy equipment and loads, a giant cableway was erected. Known as the High Line, this carrier could whisk a 25-ton load from one side to the other in a couple of minutes. Or lower it to the bottom on either side of the river just as quickly. For 2 years, the slender steel strand was to be the only means of transporting heavy loads up, down, or across the canyon. It's impossible to estimate, or even imagine, the hundreds of thousands of tons that were carried. Thus far, we have been talking about preliminaries. Now, let's see the big jobs that had to be done. Here, our scale model has been converted to show the site as it was originally. The critical task was to divert the Colorado from its age-old channel so the riverbed could be excavated and the foundations poured. That called for drilling 2 giant tunnels to carry the river around the work areas. These huge corridors would each be 41 feet in diameter and extend over half a mile through the rock. There were also a number of other areas that had to be excavated, so work could begin on the mammoth task of placing concrete in the foundation. That meant blasting out for the massive keyways that would anchor the dam on both sides of the canyon. For the cavernous spillway tunnels that would be used to control floodwaters and carry excess waters around the dam. And for a 2-mile vehicular access tunnel from the summit to the canyon floor. It would help during construction and will be the supply line to the powerhouse in years to come. In all, more than 4.5 million cubic yards of rock would have to be removed before the first bucket of concrete could be placed in the foundation of the dam. What about the time element? How long did the contractor have to complete this mammoth earth-moving operation? The river was the boss. It set the deadline. For much of the year, the Colorado is a sultry, sluggish, slow-moving puree of mud and silt. But when the spring comes and the mountains, hundreds of miles upstream, begin to disgorge their yearly harvest of melting snows, then a monster is born. The Colorado becomes a raging giant that, on occasion, has reached a velocity of 190,000 cubic feet of water per second. Any attempt to move the river must be made before the spring runoff begins. As construction began, a goal was set. Diversion would take place in February of 1959. That would be precisely 22 months after the awarding of the prime contract. Less than 2 years to complete one of the greatest blasting and tunneling operations of the 20th century. With that deadline, every phase of the operation had to follow a rigid schedule. Drilling machines working in the tunnels were committed to a specified rate of forward progress each day. Drillers working in the keyways and other exposed areas also had their quotas. They averaged some 50 feet per hour. That's a lot of ground to cover when you're working with 3 1/4-inch bits, and each must be driven up to 16 feet deep into the rock. In the final analysis, machines were the decisive factor in determining whether the schedule could be maintained and the deadline met. Glen Canyon featured one of the largest fleets of motorized equipment ever assembled for a single peacetime construction project. Each operation had its own supply problem. Each depended in some way on some piece of motorized equipment doing a specific job at an appointed time and place. The blasting crews relied on the explosive trucks, keeping them supplied with blasting powder as needed. As the drilling was completed in each new area, the trucks had to be there with the explosives to splinter one more section of the mighty balls. The most critical hauling problem was the removal of excavated materials. The assignment of handling this enormous volume of material was entrusted to a fleet of rugged diesel pay haulers. For 22 months, they were Johnny on the spot with each new blast, ready to start removing the debris, 24 tons at a time, almost before the dust had cleared. They moved like clockwork, even on grades in excess of 20%. An average of almost 10,000 cubic yards of rock, that's about 20,000 tons, was displaced daily and had to be removed promptly from 8 different locations on both sides of the canyon. Timing was all important to avoid confusion and congestion, and to maintain an orderly flow of excavated materials to other crews waiting to use them. Nothing was wasted at Glen Canyon. Every bit of splintered rock and muck was utilized. Wherever the pay haulers went, there you were sure to find the crawlers, ready to move in and level the load as soon as it hit the ground. As work progressed in the diversion tunnels, another hauling problem was born. Concrete for lining the tunnels had to be delivered from a temporary batch plant to the high line for lowering to the bottom. This was a job for the heavy-duty transports. The trucks had to synchronize their movements to the schedule of the high line. Each time the cableway brought up an empty bucket out of the hole, a truck had to be there with a full one, ready to go back down. The moment the truck was clear, back it went for a refill. Here you see the magic of Glen Canyon. Even the commonplace, a simple concrete bucket, becomes poetry in motion against the backdrop of the desert sky. One of the most remarkable features of Glen Canyon is its amazing organization for the field maintenance of its huge motorized fleet. Special duty units are on the go from morning to night. There are fuel trucks, grease trucks, tire trucks, plus a large contingent of radio-equipped pickup trucks for supervisory personnel and troubleshooters. In January of 1959, a dramatic milestone was achieved. The diversion tunnels were ready to move the Colorado from the channel it had occupied through the ages. This was the big push. Like an army carefully wheeling its forces into position, the contractor began moving equipment for the all-out offensive against the river. Every available piece of earth-moving machinery was dispatched to the floor of the canyon for the mammoth task. Both the bridge and the access tunnel were ready to assume some of the burden of moving equipment. However, the steel cableway still proved the fastest and most direct route to the bottom. It was simple. Just hook them up and take them away. Hour after hour, it kept busy, lowering a steady procession of equipment. The first objective was to remove the levees at the entrance to the west side diversion tunnel so the water could flow freely into the concrete-lined corridor. The pay haulers that had supplied the fill for the embankments were now recruited to come in and help remove them. Another levee had been built downstream at the tunnel exit. It too had to be removed so the water could flow freely after diversion. A rhythm was established, like well-trained porpoises. The huge buckets of the drag lines dipped into the river so many times each hour, each time coming up with their quota of dripping mud. Time was becoming a factor. There were reports of early thaws in the north. Any day now, the Colorado could explode into its annual spring madness. So, men and machines functioned with relentless production line precision. So many buckets to the load, so many loads to the hour. There was no let-up, even at sundown. Men and machines worked around the clock to open the new channel for the river. Finally, the job was done. The tunnel was cleared. The moment all hands had been shooting for 22 months, was here. Now, to complete the diversion. The temporary diversion dams must be closed to seal off the river completely. It looks so simple. A few well-placed loads of rock and earth should do it. But the river has a will of its own. After thousands of years, it doesn't give up that easily. There are 24 tons of fill in that load. How effective will it be in arresting the flow of the river? See for yourself. In a few seconds, it's all gone. Vanished as completely as a few grains of sugar in a boiling teacup. So, a hurry-up call is placed for pay haulers to start moving in large boulders. The bigger, the better. Some of these rocks weigh upwards of 10 tons. What can they do to arrest the fury of the stream? Not very much. They, too, are whisked away like so many grains of sand down a drain. Well, gentlemen, now what do we do? Next, large steel forms are eased into the stream in the hope that they can break the force of the current and serve as an anchor for the fill. Within the hour, the rugged forms are twisted completely out of shape and tossed to one side as the river continues ruthlessly on its turbulent way. Each of these moves takes time, and with each passing hour, the velocity of the river increases. In another few days, the Colorado will be completely unmanageable. Finally, an enormous steel frame the width of the channel is hurriedly fabricated. While it's being assembled, the whole fleet of pay haulers and crawlers is put to work, moving up mountains of fill for a final all-out effort. The huge form is wheeled into position. Inch by inch, the giant frame is eased into the angry water. Like a skillful fisherman manipulating his line, the crew painstakingly edges it into the exact center of the channel. Then, as it settles into place beneath the surface of the water, the crawlers go into action. Hour after hour, hundreds of tons of rock and fill are poured into the stream. The objective is to overpower the river. And it works. By morning, the Colorado has been turned from its age-old path. After days of tireless effort, the men and their machines have finally triumphed. For the first time in history, it is now possible to walk from one side of Glen Canyon to the other without getting your feet wet. Many other things were accomplished during that 22-month period. The town of Page has become a reality. The desert has blossomed into a community of fine modern homes and paved streets. There's a swimming pool, too. There's a fully staffed grade school that will soon be augmented by a large modern high school. A 25-bed hospital has been erected and is the largest and most complete medical facility within a 100-mile radius. And there are new churches for each of the denominations represented in Page's 8,000 inhabitants. In addition, facilities have been installed to supply the 5 million cubic yards of concrete that will be required for the dam. They include a fully automated mixing plant with a capacity of almost 480 cubic yards per hour, the largest facility of its type ever built, and the world's largest refrigeration plant. It enables concrete to be placed at the specified temperature of 50 degrees, even in the 110 degrees summer desert heat. There are also 2 new traveling tower cableways, each with 50-ton capacity. They are capable of placing 96 tons of concrete every 5½ minutes. They're so accurate that the operator can drop a bucket on a dime on the floor of the canyon from the control tower 800 feet above. Thus ended Act 1 in the drama of Glen Canyon. Act 2 begins in a holiday atmosphere. The Navajos come in to mingle with the construction workers and tourists to mark the milestone. The first bucket is ready for the foundation. It carries 12 cubic yards of concrete. Ultimately, enough will have been placed to pave a 4-lane highway from Phoenix, Arizona to Chicago. Now a new army of workers takes over to handle the most dramatic phase, the placing of the concrete. Nearly 3 years will be required to pour the mountains of concrete needed for the massive structure higher than a 70-story building. Again, a rhythm is established. Fill the bucket. Drop a bucket. Place a bucket. And return a bucket to start a new cycle. 4 buckets every 5½ minutes. Fill, drop, dump, and return a bucket. Night and day for 3 long years. So now a new structure starts to rise, and like the bridge, this great dam will be a bridge to the future in the development of the upper Colorado River. 35 years of planning. 2 years to complete the excavation and divert the river. 3 years to pour the concrete. Another 5 years to fill the Great Lake. What are the benefits that will accrue to the region and the nation from this monumental expenditure of time, energy, and money? For one thing, with the upper Colorado under control, it will be possible to build irrigation projects to bring enriched and diversified farm production to the upper basin. The availability of vast hydroelectric power will lead to the establishment of new communities and industries. And cities will follow. The development of great urban areas is inevitable because all of the requisites for good modern living will be present in abundance. In addition, Glen Canyon Dam and the 186-mile Lake Powell, which it will create, will certainly become one of the West's great scenic attractions. Already more than 500,000 Americans visit the site each year to marvel at the impressive structure rising in the desert. And this number will certainly multiply as scenic areas are opened by the new waterway. These are no idle dreams. They are fast becoming realities here, as similar miracles have occurred elsewhere in the West. New economic horizons will emerge because men of imagination have planned it so, and because they have the courage and the perseverance and the machines to do the job. The combination of men and machines has always been an irresistible force for progress. The new world that's being born at Glen Canyon is one more example of that truth, and it will be an enduring monument to the fine Americans who built it.